Welcome to Brain Vision.
So once again, welcome to a new problem. This time we're still dealing with momentum. We have two birds that are flying towards each other. So along the y-axis, okay, um, um, we have a falcon, okay, which has a mass. So I'm going to call it MF of 600 grams. So this is the information that we're given. So it's 600 grams. We can change that right away to kilograms. So 600 becomes the same as 0. 0.6 kilograms, or if you cancel those three, so 0. 0.6 kilograms, and it's flying in the south north direction. If you think of going upwards as your y, or your positive y. Um, and that's the falcon. And then we also have a raven that's flying this way, and the raven has a mass that happens to be 1.5 kilograms. That's the mass of the raven. We also have an initial velocity. Um, of the falcon. So I'm going to call that Fi, and that happens to be 20 meters per second. And then the two of them collide. Okay, so they collide with each other, and the raven veers off. Raven veers off at an angle which we're going to call theta. The velocity, that's going to be the final velocity of the raven. So it's we have to think about the initial velocity of the raven, which happens to be v, or rather v raven initial velocity happens to be 9 meters per second. So it's heavier than the falcon, and it's flying at 9 meters per second. Its final velocity is the same as, we don't know what that is. We don't know what the final velocity of the raven is, but we do know that it has two components. The x component, this is positive x, happens to be v raven final velocity in the x, and that's simply v raven cosine of theta. And then also this other component is the final velocity of the raven in the y, and that's the same as v raven sine of theta. That's the information we're given. So we do have the masses, we do have the velocities, and also the final velocity. When they collide, the falcon is going to bounce back with the final velocity. So final velocity of the falcon is the same as 5 meters per second. It's the same as 5 meters per second. So these are the paths of motion. This is the information we're given. We have a raven and the falcon flying towards each other. They collide, and the raven has to fly off at a specific angle, which we call theta. So that's what we're given. And then we want to find in part A, we want to find the angle, the theta itself. We want to find that. That's one thing we want to find. The theta, which is the direction of motion of the raven. Direction of motion of raven. And then also part B, we want to find out the final speed. So VR final of the raven after collision. Final speed of raven after collision. That's the information we're given. We have the x-axis and the y-axis. We have all that information. We also know that the velocities are going to be resolved. So the first thing we're doing is we need to find the momentum. Okay, so we're going to have to think about the momentum in the x direction for both the raven and the falcon. Remember, the falcon is only moving in the y direction, so no momentum in the x. So we don't account for any momentum in the x for the falcon. So the momentum will only be focused for the raven. The initial momentum in the x equals to the final momentum in the x. The initial momentum of the raven is mr, so the mass times the initial velocity, VRI. Okay, and that's going to equal the final momentum of the raven in the x direction. So that's mass of the raven times the final velocity of the raven in the x. The m's cancel out. We can replace the final velocity of the raven by saying VR cosine of theta. Okay, so this is our initial step. That's the behavior of the system in the momentum in the x direction. So we're using the law of conservation of momentum. Law of conservation of momentum. In the next page, we're going to continue the problem. This time we'll focus on the momentum in the y direction. And that's the total momentum in the y direction. And that accounts for both the raven and the falcon. Okay, the raven and the falcon. The initial momentum in the y equals to the initial momentum, the final momentum in the y. This is according to the law of conservation of momentum. So we have to think about the raven. If we go back in the y direction, we're seeing there's a component right there. The y component, it's in the positive direction. So mass, we have to think about the initial first, which is this one right here. So this is our initial. So initial velocity of the in the y direction, we have the raven. The initial velocity of the raven in the y direction would be the mass of the raven times the initial velocity of the raven. Let me see. We have to use the right convention. So mass of raven, yeah. So mass of raven and initial velocity of the raven in the y direction. That happens to be 0 meters per second because it's not moving in the y direction. And then plus, we also have the falcon, the mass of the falcon times the initial velocity of the falcon. This is in the y direction. Okay, in the y direction, it's we're calling it Fi, but strictly speaking, this should have been y in the y direction and the final velocity in the y direction. So we can say that this has to equal the final velocity of the raven in the y direction plus the mass of the falcon times the final velocity of the falcon in the y direction. And so, this part is going to be 0. We have the mass of the falcon times the final velocity of the falcon in the times the initial velocity of the falcon via Fi equals to the mass of the raven times the final velocity of the raven in the y direction, and that's this one, the final velocity of the raven in the y, Vr sine theta. Vr sine theta. Okay, remember Vr is, well, actually we should call it Vr final. Okay, Vr final. Yes, we want to call it Vr final. A lot of variables here, so you want to be very careful about the process. And then we also need to find the final velocity of the falcon in the y direction, which is 5 meters per second, times final velocity of the falcon in the y direction. That's the scenario we have at the moment, and our goal is to come up with an expression that's helpful to help us solve our problems. So we can see that the mass, so mr, so this is just algebra, Vr final sine theta becomes equal to mf vf initial minus mf vff final. And if we move that up, we end up having the Vr final, that's the final velocity of the raven in the y direction, Vr sine theta, equals to, we simplify that, we have mf, we divide both sides. So what you're doing is we're pretty much dividing these two by the mass of the raven. Okay, we can pull out the f right there, so Vi minus v final velocity of the falcon, the initial velocity of the falcon in the y direction, minus the final velocity of the falcon in the y direction. So that's kind of what we're doing right now. So we just want to make sure the process is right. Mass of falcon minus, oh, you know what? This one right here is gonna be a minus. This one is a minus because it's in the opposite direction. Let's just verify that. You see this is -5, so this is a minus. This is going to be a minus because it's going downwards. Positive y is upwards, negative y is downwards, negative x is on the other side. So you want to make sure that this is a minus. This one is a minus, and this one is also a minus. Okay, those two are minuses, and that means if we move this one to the other side, it's going to become a plus. So this has to be a plus also, divided by the mass of the raven. That's what we have at this point. Our goal is to find theta. We're going to do that in the next page. So we have two critical equations. The first one is the initial velocity of the raven. So the initial velocity of the raven is the same as, we should call this in the x direction. We should call this in the x direction. So the initial velocity of the raven, not just in general, is Vr cosine theta. And then the other equation that we can use is this one. So final velocity of the raven. So one component is in the x, and the other component is in the y direction. So the initial velocity of the raven happens to be VR cosine theta. That's what we're saying. And then we also need this other piece of information, the final velocity of the raven, VR sine theta. So VR sine theta, actually it's VR final sine theta equals to MF V final initial, velocity of falcon, the initial velocity of falcon in the y direction, plus the final velocity of the falcon in the y direction over the mass of the raven. So this is kind of where we are right now. This is the information we're processing, and we want to say that tangent. So we take this equation. Okay, we take that equation and divide it by that equation. Okay, so if you we take the equation VR final sine theta divided by VR cosine theta. So you have to go back and see this was the final velocity. So this should be F. Just verify that. Okay. So again, just to clarify things, we have to get the momentum in the x direction, and that's law of conservation of momentum. Momentum in the x is the same as the initial momentum in the x is the same as final momentum. We don't have to deal with the falcon, so we only focus on the raven. So mass of raven times initial velocity of the raven in the x direction, if you want to call it that. This one too would be the initial velocity of the raven in the x, because it's the same thing, equals to mass of raven times final velocity in the x. So then VRIX, that's what it is. And then the second part, we're dealing with the y direction. For the raven, we don't have the initial velocity in the y direction is 0, but then there's a final velocity in the y direction. For the falcon, we have an initial velocity in the y direction, so we add that subscript, and then this is equal to the mass of the raven times the final velocity in the y direction for the raven minus the mass of the falcon times the final velocity of the falcon in the y direction. So this is the raven momentum, final momentum in the y, and this is the falcon final momentum in the y. We solve that. We continue with the solution, and that helps us find the final velocity of the raven. So there's something about the final velocity of the raven, and this is it right here. This is it. That's the final velocity of the raven. So now we have these two components. Going back, you can see this was supposed to be VRF. VRF is just the final velocity of the raven. Okay, so we have to see that velocity of the raven, final velocity of the raven. That's what we're dealing with. Final velocity in the VRF, final velocity of the raven. So we're in good shape. Okay, and then we're taking this equation, the second equation, and dividing it by the first equation, and that's what we did here. Remember, the first equation has that, so we're going to end up with tangent of theta. Okay, because these two cancel out. So if you take, it's almost like you're doing something like that. VR final cosine theta equals to VR initial That's the initial velocity of the falcon, or you could call it initial velocity in the x if you want to. It's the same thing. Doesn't make any difference. And so if we simplify that, we get that the tangent of theta happens to be this part of the equation. So mass of falcon over velocity of the falcon in the y direction, the initial velocity of the falcon in the y direction, plus the final velocity of the falcon in the y direction, all over the mass of the raven, times this part comes right here. It comes up, so times the initial velocity of the raven, or you can call it just initial velocity of the raven in the x. Doesn't make any difference. And so if we want to find theta, we have to do a tan inverse. So if a tan inverse of this all this expression in the bracket, so mass of falcon, final velocity, initial velocity of falcon in the y, plus final velocity of falcon in the y, all over mass of raven times initial velocity of raven in the x. So it's a mouthful of variables. In the next part, we just have to plug in the numbers. So theta becomes equal to tan inverse. Okay, tan inverse of 0.6 kilograms. That's the mass of the falcon. Times the initial velocity of the falcon in the y, and that, remember, happened to be 20 meters per second. So 20.0 meters per second, initial velocity of falcon in the y, plus final velocity of falcon in the y direction over the mass of the raven, which is 1.5 kilograms, 1.50 kilograms, times initial velocity in the x of the raven, which is 9.0 meters per second. So this is a fairly involved, lengthy problem with expressions, but it's very doable. And so we end up getting our theta, our angle, is 48 degrees. And remember, if you can recall the sketch, the raven is flying that way, falcon is flying that way, and then bouncing off. And then there's this angle right here, theta, that the raven makes off when it veers off. So that's part A of the problem that we're looking for. And then in part B, we want to find the final velocity of the raven. Okay, so if you can recall from this relationship, this will help. We see that the initial velocity of the raven in the x, so the initial velocity of the raven in the x equals to the final velocity of the raven times cosine of theta. Okay, final velocity of the raven times cosine of theta. And so our goal is to get the final velocity of the raven, that one. That's going to be RF, the initial velocity of the raven in the x, over cosine of theta. The initial velocity of the raven in the x is 9.0 meters per second. And now we do have the angle, which is 48 degrees. And so we end up with a solution for the final velocity of the raven, which is 13.5 meters per second. So hope you enjoyed the problem. We have the raven and the falcon. The raven bounces off that way at an angle of theta. This is the final velocity of the raven that we want to look for, and this was also the angle we were looking for. So using the law of conservation of momentum, we compared the initial and final momentum in the x, and then we compared the initial and final momentum in the y, and then we came up with two expressions, one built from the x direction, one built from the y direction. We simplified one on top of the other, and that we were able to get a tangent. Remember, tan theta is sine theta over cosine theta. Plugging in those numbers, we were able to get the value of theta, which is 48. After getting the value of theta, we went back to our initial expression derived from relationships between momentum in the x, the initial and the final. So we used that, and then we plugged in these numbers and were able to solve for the velocity. Hope you enjoy the problem. Feel free to send any questions my way, and I hope you have a wonderful day. Okay, thanks. Bye.